All right, so differential calculus. Now, firstly, you need to know the rules of differentiation. Just those simple rules of differentiation. Starting first, let me mention the sum and difference rule, which you already know. Like the sum and difference rule, if you have y being equal to x squared plus 3x minus 4, you know that dy over dx is going to be, you drop the 2, okay, you reduce the power by 1, and then you go to the 3x, that will just become 3, right? The constant becomes 0. So this is the derivative. That is basically the sum and difference rule. So it's the very simplest, and you'll be given some things like you want to find the derivative of square root of x minus, let's say, 3 divided by square root of 4x to the power 3. Something like this. You want to find the derivative. So this, just write the power, it becomes power half minus a 3. What is in the denominator here? We know that square root means to the power half. So this is the same as 4x to the power 3 and then to the power half instead of writing the square root. Meaning that if I take it on top, of course I can multiply this 3 with the 1, so that will be 3 over 2. If I take it on top, meaning that it will be the 4x, and then it becomes negative 3 over 2 power. Okay, meaning that the derivative dy over dx is going to become, bring down the half, and then to be x to the power negative 1 over 2. Like from half, if you subtract a 1, that will be negative 1 over 2. Then bring down the negative 3 over 2, so it becomes positive because it was negative. So 3 times 3, that would be 9 over 2. And then we're going to have 4x, the negative 3 over 2, subtract a 1, that would be negative 5 over 2. So this is going to become, the x here, since it is negative, is going to go in the denominator. So I'm going to have 1 over, remember in the denominator already have a 2. So if it goes in the denominator, I'm going to change it to into square root because it was it would become positive power half. Okay, and then plus we've got these two can it divide? No, it cannot divide with a 4. Okay, it cannot divide with a 4. So basically what we are going to have is 9. So never cancel this, like never do that. Because it can't. 2 cannot go into 4x if it is raised to a power, unless if it was just alone like that without that power. Okay, so that will just be 9 divided by 2. And then this thing, when it goes in the denominator, becomes now 4x to the power 5 over 2. Okay, so this is going to be it. Of course, we can simplify it more than that if we want, but we're able to end there. So that's basically the sum and difference rule. The other one we need to know is the chain rule. We can also refer to it as the power rule. So for the chain rule, what you have is a chain, more like a chain. It can have a power or not. Okay, for example, when you have got y is equal to, let's say, 4x squared minus 3 and then to the power 7. To find the derivative for this one, dy over dx is going to become dy over du multiplied by du over dx. In other words, what you do here is what is inside the brackets, you are going to equate it to u. So you are going to become y is equal to u to the power 7. That's why we're saying dy over du, because we're differentiating y with respect to u. And what is u? Remember, u is what is inside the bracket, which is 4x squared minus 3. And again, we'll differentiate u with respect to x, since you have already differentiated y with respect to u. And then what you're going to do is just get to multiply that. So basically what you do is just drop the power, write what is inside the sum, reduce the power by 1, and then go to the inside, 4x squared minus 3 differentiate, that would be 8x. Okay, so this is the derivative. Just multiply the 8x with the 7 in front there. Then you found the derivative also for that one. Basically, that's the chain rule. Apart from that, we have got the product rule. And product rule is equivalent. If you're talking about integration, you're going to talk about differentiation, I mean integration by parts. So it comes from the product rule. Okay, the differentiation integration by parts comes from the product rule. So you need to know it so that as we are going to be talking about integration, you will see how the by parts comes about. So this one, when you are talking about the derivative dy over dx, you are going to get v du over dx and then plus u dv over dx. In other words, you've got a product of two functions. So what you do is you maintain one, differentiate the other, and then you maintain the other, differentiate the one. For example, when you have y is equal to, let's say 4x minus 7 to the power 2, let me say to the power 3 multiplied by, let's say 3x squared, okay, like that. So here we've got a product of two functions. So the derivative dy over dx becomes, I can take, like, if you consider the alphabet, u comes first and then v. So from the formula, I'll first write v, that is the second part, 3x squared, and then I differentiate the first part. Now to differentiate the first part, we're going to use the chain rule. So I'll drop the power, I write what is inside the same, I reduce it by 1, and then differentiate what is inside. Okay, it will just give us a 4. And then plus, I'll maintain the first thing, which is the 4x minus 7 to the power 3, and then differentiate the second thing, so that will become 6x. So just simplify, you can multiply this 3 times this 4, that will be a 12, and then multiply by a 3, so that will be 36. And then we have got x squared, and then we write the 4x minus 2 to the power 2, that minus 2 minus 7 to the power 2, and then plus, I'll write the 6x in front. We have got 4x minus 7 to the power 3. So here we can factorize out 4x minus 7. So that will be 4x minus 7. I'll factorize out to the power 2 since 1 is to the power 3. And then we are going to remain with, here are going to remain with only 36 x squared, and then plus, here are going to remain with 6x, and then 4x minus 7. One of it is going to remain since we just removed power, the power 2. So basically this is going to be the answer. If we want, we can simplify it the more, 4x minus 7 to the power 2. This is going to be 36x squared plus 6 times 4, it should be 24x squared minus 7. So add like terms together to be 4x minus 7 squared, and then you're going to have 36 plus 24, that is the remainder 1. It is going to be 60x squared minus 7. So this is going to be the answer, simplified in the lowest term. The other rule when you're talking about fractions is a quotient rule. Okay, so for that one, I'll just write a formula. And then we're going to use some different examples as we get to go on with some other special derivatives. So every time you see a fraction, you should know that you are going to use the quotient rule of differentiation. But you can as well convert it to the product rule if you want to make it a bit simple. Okay, so whenever you have got a function, let's say y is equal to u divided by v, you need to know that whenever you've been given a fraction, the v will always be in the denominator. Like u comes first in the alphabet, right? So it will be on top. So the derivative dy over dx is going to be, you get what is in the denominator, differentiate what is on top, minus you get what's on top, you differentiate what's down, and then divide everything by what is down squared. So that is the quotient rule, but we'll understand it more as we get to to do these differentiations. Now, you need also to know how to differentiate trigonometric function. So that is trig derivatives. How do you differentiate sine? How do you differentiate cosine? How do you differentiate also tan? Like that. And also their inverses like the cosec and these other things. All right. So what we are going to do is I'm going to take the y-axis. The y-axis I'm going to make it sine. I'm going to get the negative y-axis as negative sine. The x-axis as cosine. Negative x-axis as negative cosine. Now when you are going in this direction, in the clockwise, this is going to tell you that you are differentiating. Meaning if I differentiate sine, I'm going to get cos. If I differentiate cos, I'm going to get negative sine. Differentiate negative cos sine. Now if you swap, instead of putting the sine on the positive y-axis, you put the sine here and then the cosine here. Meaning that you are going to change the direction. You are going to be going like this. That will mean differentiation. Okay, so never swap them. Always take the positive y-axis as sine if you want to go in this direction. Otherwise, if you start going in this direction, that will show integration. If you integrate cos, you get sin. If you integrate sin, you get negative cos. Just like that. Is this okay?
Yes.
Okay, now that we know this, I think one thing that you should just know is if you just know that sin, the derivative for sin gives you cos, the rest you can know them. You just put down this table. Okay. So let's say we've been asked to find the derivative for y is equal to, let's say, sine x squared. How do you find the derivative for this one? So the derivative dy over dx is going to be equal to, get the sign, differentiate. You know that that will give you cos. Maintain the angle the same way it is. After you have done, now differentiate the angle. X squared, that will give you 2x. When you're writing, the 2x is supposed to be in front and then cos x squared. So this is the derivative for y is equal to sin x to the power 2. And then when you have got y is equal to, let's say, cos cubed x, you want to differentiate. You need to know that cos cubed x is different from cos x cubed. This means it's the same as cos. Okay, you have got cos x. Now these three, you can write it outside like that. That's the meaning. So the derivative dy over dx, the rule we are going to use is the chain rule, the power rule. So I'm going to drop the 3, write the cos x the same way it is. Okay, reduce the power by 1 so it becomes power 2. But now go to the inside, you differentiate the cos. If you differentiate cos, you get negative sign. Okay, like that. So we can simplify this as 3 times negative sign. That will be negative 3 sine x. And then you have got cos squared x. Is this okay?
Yes.
All right. So it can become more and more nice. Let's say it is y is equal to sine to the power 4, and then you have got x squared. This is what you want to differentiate. Remember, if you've got sine to the power 4 x squared, this is the same as sine x squared and then to the power 4. So the derivative dy over dx is going to be equal to, first drop the 4, write the sine x squared, reduce the power by 1, becomes power 3. Okay, times, now go to the inside, differentiate sin, you know that will give you cos. Keep the angle the same way it is. And then after that, now differentiate the angle. X squared, that will give you 2x. Okay, you see now we are moving. So I can multiply this 2x times the 4, that will be 8x. And then I'll write the cos because it has got a lesser power. And then I'm going to write the sine because it has got power 3. And then I've got x squared. So this is the derivative. Just a moment, it seems the network has paused. Okay. So I don't know if should I repeat? Should I
Yes, on
on
here
where?
on. So you're supposed to just the first part here. You're supposed to put this and the X together and then remove the four. I didn't get the class like you did here, but this way I
Okay.
can do.
So the first thing that we did was sine to the power 4x squared means sine x squared and then the 4 outside. So the derivative dy over dx is going to be you bring out the 4 down and then you write the sine x squared, reduce the power by 1, it becomes power 3, and then go inside the brackets. Now the first thing you should be able to work out is the sine itself. So if I differentiate sine, I'm going to get cosine. Maintain the angle the same way it is. And then if you finish that, now differentiate the angle, that will give you the 2x. So now multiply this 4 with the 2x, that will give me 8x. I'm going to write first the cos x squared and then I write the sine cubed x squared. So this is it. Is it okay now? I cannot get you.
I said yes. It's clear.
All right. We can look at one more example before we do something else. So when you have got y being equal to, let's say, cosine of 2x. For this one, dy over dx is going to be equal to, first thing, differentiate cos. That gives you negative sin. Keep the angle the same way it is. And then differentiate the angle. If you differentiate 2x, you're going to get 2. So this is just the same as negative 2 sine 2x. So if you add y being equal to, let's say, sine to the power 3 of, let's say, 4x squared minus 1. Remember, this can also be written as y is equal to sine of 4x squared minus 1, and then everything to the power 3 because the 3 is outside, is on scene. So this one, the derivative dy over dx is going to be bring down the 3. You write the sin, reduce the power by 1 so it becomes power 2, right? And then keep the same way the angle is 4x squared minus 1. So all I've done is I just brought the 3 down and then reduced the power by 1. If I'm done with that, now I'm going to multiply. I differentiate what is inside. I differentiate sin, I'm going to get cos. Maintain the angle the same way it is, 4x squared minus 1. If I'm done with that, times, I'll now differentiate the angle. 4x squared minus 1, that will be 8x. So now write this together. So I'll multiply the 3 by the 8, is that a 24x? And then I'll start by writing the cos 4x squared minus 1. And then I'll write the sine squared 4x squared minus 1. So this is it. We are good.
Yes.
So before I continue with more questions, okay, let me first do the turn, and then we can look at the implicit so that we can connect well. So now when you want to find the derivative for y is equal to tan x, we need to know that tan is the same as sin x over cos x. So for this one to differentiate, we are going to use the quotient to dy over dx is going to be v du over dx minus u dv over dx divided by v squared. And this will be v is what is in the denominator, that is cos x. And then differentiate what's on top, that's sin. We know that if we differentiate sin, we are going to get cos x. Minus, write what is on top, that is a sin x. Differentiate what is down, the cos. We know that if you differentiate cos, we are going to get negative sin x. And then write what is down squared, that is cos x. So it becomes squared. Cos times cos, that is cos squared x, negative sign, positive sign, squared x over cos squared x. So this is going to give us cos squared x plus sin squared x. We know that is a 1. Okay, from there, just a first rule of identities. And 1 over cos, like the reciprocal for cos is a sec. But because this is 1 over cos, this is going to be sec squared x. So every time you differentiate tan, this one you need to know by heart. Every time you differentiate tan, you get sec squared, because we'll not have time to start showing all this process. So the derivative for sec for tan is sec squared. Now I want also to show you the derivative for sec so that the rest you can be able to get them yourself in case they came. So let's say we've been asked to find the derivative for sec x. We know sec x is the same as 1 over cos x, meaning that we are also supposed to use the quotient true. Okay, so this is going to become v, that is what is down, cos x, and then differentiate what's on top. If you differentiate 1, you get a 0. Minus, you write what is on top, which is when a 1, differentiate what's down, that will give you, if you differentiate cos, you get negative sign, and then divided by the cos squared. Cos times 0, that's 0, and then negative 1 times negative sin, that will be positive sin x divided by cos squared x. So this is the same as sin x divided by cos x cos x, because it's cos squared. Now sin over cos, what do we get?
Tan and
That,
then sec.
okay, so that will be tan x sec x. So every time you differentiate sec, you get tan x sec x. This one you also need to know. So let's say we have been asked to find the derivative for y is equal to tan cubed x. You know tan cubed x can also be written as tan x and then cubed. So meaning the derivative dy over dx, just drop the power, then it becomes tan x squared, and then differentiate what is inside. If you differentiate tan, you get sec squared x. So this is going to give you 3 tan squared x sec squared x. So this is going to be the answer. Okay, that will be the answer for this one. So if you add y is equal to, let's say, sec, can we say sec 4x? So this will become dy over dx, giving us, first differentiate sec, that will give you sec x. Now, if you differentiate sec, not sec x, please you always make sure that you maintain the angle the same way it is. If you differentiate sec, supposed to get tan, the angle same way it is, tan 4x, and then sec 4x. And then now differentiate the angle that you are going to you get 4. So the answer is 4 tan 4x sec 4x. So this is it. Good.
Yes.
So now implicit function derivatives. How do you differentiate implicit functions? Now an implicit function is a function that is not expressed in terms of y. Like most of the function are expressed in terms of y. Y is equal to x cubed, y is equal to this. But an implicit function is not expressed in terms of y. For example, xy is equal to 2. This is the question. Find the derivative. So to find the derivative of such a question, I'll just put d over dx. Okay, and then everything I'll put it in brackets. Now here you can see you have got a product of two functions. So what you do is use the product rule. First maintain x, okay, differentiate y. So if I differentiate y, I'm going to get 1. Every time I differentiate y, I'm supposed to add the y on top there, dy over dx. And then plus, since it was a product, I'll now maintain y. I differentiate x. If I differentiate x, I'll get 1. Every time I differentiate x, supposed to put x here, so it becomes dx over dx. But dx over dx is 1, so that's why if you differentiate x, you don't put anything, all right? And that will be equal to, we differentiate 2, that will give us a 0. So this is going to be x dy over dx is equal to, I'll take negative y, the other side becomes negative y. So it remains with dy over dx, divide both sides by x to be negative y over x. So that will be the derivative. So let's say we have, what can I say, square root of x cubed plus xy. Let's say plus y cubed or y squared is equal to 2. You want to differentiate. So first thing first, remove the square both sides. Remove the square root. So that gives you now x cubed plus xy plus y squared is equal to 4. Now you can differentiate. So I'll put d over dx just in front here. So the derivative of, yes, Elizabeth.
Yeah, so if I had removed the square root by putting 1/2, and then
It would be okay, but trust me, for you to get an answer for that one, you have to suffer. Like it, if you put power half, that means you have to use first the chain, after the chain will come to the inside. It is just a long way of doing the same thing, but it will be so long such that others, at one step, you are going to mix up.
okay.
All right, so we're going to differentiate x cubed. That is going to give us 3x squared. Every time we differentiate x, add x there, it will be dx over dx, which is just 1, right? So there's no difference. And then plus, now we differentiate xy. So first keep x, you differentiate y. If you differentiate y, get 1. Now every time you differentiate y, add dy over dx. And then get y, the same way it is, differentiate x, that will give you a 1. And then differentiate y squared, that will be 2y. Every time you differentiate y, add dy over dx. If you differentiate 4, you are going to get a 0. So every time that has got an x, I'll put it together. I mean, what has got dy over dx, I'll put it together. So this one and this one. Actually, I'm going to factorize out the dy over dx. So what remain with is x plus 2y. And then any other term, I'll take it the other side. We're going to have negative y and negative 3x squared. So to remain with dy over dx, divide both sides by x plus 2y. So that will be negative y minus 3x squared divided by x plus 2y. So this is the derivative. We are good?
Yes.
Okay, just a last example on implicit function derivatives. That is, which are in linear form like this. And then we can combine also with some trig. So when you have, let's say, uh, 3xy squared plus, let's say, the square root of y, okay, minus 4 is equal to x. You want to differentiate. So you put this in d over dx. Now you can see I've got 3xy squared. That's a product. Now 3 is a constant. So I'll first remove that 3 outside like that. Okay, so remain with only xy. So I'll first keep x. I differentiate y. What are we going to get? We are going to get a 2y. Every time we differentiate y, you add dy over dx. And then plus, I'll maintain the y squared. I differentiate x, that will give me a 1. Don't forget about the 3 there. And then plus, we're going to differentiate square root of y. We know that is the same as y to the power 1 over 2. So drop the 1 over 2. Then y subtract a 1, negative half. Every time you differentiate y, add dy over dx. If you differentiate the negative 4, that will be 0. So that will be equal to, if you differentiate x this side, that will be a 1. I can now distribute. This is going to be 3 multiplied by 2, that is going to be 6xy dy over dx. 3 multiplied by the y squared, that will be 3y squared. Then plus this y to the power negative half. If it goes down, it becomes positive half, and positive half is the same as square root. So that will be 2 square root of y. Like the 2 is already in the denominator. Okay, remember there is also dy over dx. That will be equal to 1. Every time, everything with dy over dx, I'll put them together and then factorize out dy over dx. So this one and this one. So I'll say dy over dx, open bracket, 6xy plus 1 over 2 square root of y. That is going to be equal to 1 minus, I'll take this time the other side, 3y squared. So what I'll do first here is we need to merge this thing that has got dy over dx in the brackets there as a single fraction. Okay, so that is going to be dy over dx. If we merge this as a single fraction, this is going to be over 1. So multiply these two. That is going to be 12xy square root of y. And then multiply this one with what is on top there, plus 1. Then over the two denominators, multiply them. That will just be 2 square root of y. The over reaches to the end, and that is going to be equal to 1 minus 3y squared. So if I want to do away with this portion so that I just remain with dy over dx, I'll multiply everything by its reciprocal. The 2 square root of y is down, I'll put the 2 square root of y on top. And then the 12xy square root of y plus 1 is on top, so I'll put it down. So dy over dx then becomes, this will cancel with this. And then the same thing, this multiplies the other side. So that will be 2 square root of y, open brackets, 1 minus the 3y squared over 12xy square root of y plus 1. So this is going to be the derivative. We are good?
Yes.
Alright, so we'll get to pause here and we are going to finish up with other derivatives.